Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to part 8 for our Pixel Platformer series in Godot. This series was made possible by the people who support me and my channel by purchasing my Godot course. There's a link for it in the description as it's currently on sale till the end of this month, so about a little less than a week now. You can check that out if you're interested. It's in the description and the pinned comment below. In this video, we're going to be adding ladders to our game, and we're also going to be discussing a simple finite state machine for our character. Now, I've got this set up with some different potential videos that we can do in the future. I made a Trello. I've been trying to think about the scope of this series because since this is a simple platformer, I kind of want to finish up this series and get on to a different series. In particular, I'd like to try something in 3D, although I don't know exactly what I'll be doing yet, so maybe it won't be 3D. But this is what I was thinking. Today we're going to be doing ladders plus a simple finite state machine, and then I have 7 other topics that I'd like to cover. A couple more enemies, checkpoints, exit door with level transitions to a new level, keys and doors, that's a pretty simple one. Clean up the character controller a bit with a double jump, coyote jump, jump buffer, and adding some basic sound effects using chiptone. So this is what I have planned as kind of like the future, and this will put us at about 15 videos total. So we're on video 8, that would be about 7 more after this, which puts us about pretty much 3 weeks out from finishing this series. So some of you have been asking about the scope of this series, and this is what I'm thinking for the scope of this series. I don't want it to be too big. Okay, let's get started. So the first thing we're going to do is we're going to create our ladder scene. So we'll create a new scene. We'll come to other node and we'll make it an area 2D because we want to be able to detect overlap here. And we'll call it ladder. We'll attach a sprite node here to it. Whoops, if I can spell sprite. We can use a normal sprite. We'll turn off centered. And we'll drag over our tiles packed. You could make a tile set for this instead of a sprite. And that's not too, that would complicate it a little. So we're gonna go to region enabled, come down to texture region. And it's a little hard to tell with just pixel snap, so we'll use grid snap again. And we need to make sure to set this to either 9x9 or 18x18 because that's what this that's what this grid is set to. It's 18x18, but we can get away with 9x9. Okay, and then we'll just select our ladder here. Okay, so we've selected the ladder. The reason using a tile set complicates things a little bit, we'll save it here, is because then you have to worry a little bit more about different collision layers. In this example, we can just put the ladder on the world collision layer. So it doesn't need to target a mask, we'll just stick it on the world collision layer. And we need to give it a collider. We'll do a collision shape 2D and select a rectangle shape. And then we'll just align this to the whole ladder. Well, we're going to attach a script to it, and this script is actually just to give it a class name so that when we're detecting it, we can make sure that we're detecting a ladder and not another world element inside of the game. Now again, if you set this up on a tile set, you could give it a collision layer that was unique to it, and then have our player, when it's detecting it with a raycast, it would detect that collision layer. But we're just going to do this. We'll come into our world scene, we'll instance our ladder. Well, we can just drag it over. So we'll find ladder, drop it here, and then I'm just going to duplicate this with selecting the node over here, hitting Control D, and moving this down with each duplication. So now we've got a ladder for our player to climb. And this is an area 2D. but we obviously have no code to be able to climb this ladder yet. So we'll come into our player scene and we're going to add, I'm going to use a raycast for this, and I found raycasting to work well. You could use an area 2D, but then you'd have to loop through all of its collisions to try and see if it's colliding with a ladder. And the raycast, I don't know, either one works, but I found in this situation the raycast was the way to go. So we're adding a raycast, and we're going to call this ladder check. We'll name it ladder check. Now, obviously, by default, raycasts are turned off, so we need to enable it. And we need to tell it which collision layer to target. We can just use world here, since our ladder is on the world. However, there's another sneaky part here, which is collide with. Currently, it's set only to collide with bodies. We actually want it to only collide with areas, because we don't need this raycast to collide with bodies. It's going to collide with the ladder is all. So I guess if you turn off bodies, we technically don't need this class name check, but we'll just use it anyways. Just in case you have other areas that are on the world layer, you want to make sure that your ladder check only detects the ladder. So now we're going to come to the top of our player script, and we're going to add a new onReady var. And we'll call this ladder check. And we'll set this equal to ladder check so we can get access to it. Now we're going to make a function here to make our life a little, oh yeah, we can get rid of this power up function too. We don't need this anymore. That was just the last video I was giving an example. But we're going to create a function here to make our life a little bit easier and our code a little bit cleaner when we're checking to see if we're colliding with the ladder. So we're going to say is on ladder. So this will be our function, and we'll just say ladder check. Let's see if we can do return. Ladder check, if I can spell it, is colliding. No, let's see. How do we do this? I know a better way to do this. We'll say if ladder check is colliding, dot ladder check dot is colliding. That's my bad. And we want to do not. So if it's not colliding, return false, obviously, because we're not on a ladder. However, there's another check that we need to make, which is we need to make sure that our ladder, or that the collision that the raycast is colliding with is actually a ladder. So we can say var collider is equals ladder check dot get collider. So now we can get the collider, and then we can say if collider, or if not collider is ladder, return false. So here's our other exit case. So if we're not colliding at all, then we exit with false. We're not on a ladder. And if the collider that we're colliding with isn't a ladder, we also return false because we're not on a ladder. And then finally at the end, we can just put return true because we've checked for our two exit cases, and then we can just return true. So now we can easily determine whether or not we're on a ladder. And we can put this inside of our physics process. We can say if is on ladder, print on ladder. Okay, putting this at the top of our physics process. And we want to update our raycast too. This is not a good raycast the way that it's set up right now. I'm going to move it up. Click on our raycast. I'm going to move it up to nearly the top of our character, and then set it to cast down 8. No, that's not far enough. We want it to come down. here to the feet. 16. It's a little too far. 15. That works, okay. In fact, yeah, that should be fine. Now just know that this arrow at the end of the raycast doesn't actually represent the length of the raycast. It's pretty unfortunate that it's set up that way, but if you imagine our raycast comes from here and it goes down to right here, okay? It doesn't actually go all the way to the bottom of this arrow, it goes right here to the end. So that's unfortunate that that's how that works and how it's represented in the game here, but just keep that in mind. Now if we run the game and we look at our output, we can see there's no printing because we're not colliding with a ladder. And then if we come over here and we touch the ladder, it starts printing on ladder. And printing is pretty processor intensive, so it's gonna probably lag to print this many print statements. But we can now tell that we are on a ladder. So we can get rid of this. That was just to make sure our function was working. And if yours isn't, make sure it looks like this. And make sure your raycast is set up properly, where it's enabled and only colliding with areas. Okay, so the next part of this video is the state machine, because we need to have a state machine in order to set up our climb state. State machines can get more or less complicated depending on your scenario and how complicated you need them to be. More complicated state machines give you more control over certain situations like transitions between states, having multiple states potentially. But we're not going to need that for this thing. And I tend to find that simpler state machine implementations are better. So I tend to recommend that you go for the simplest one that your project can do. So if it needs a more complicated one, like if you're working on it and you realize that this state machine isn't going to work for you, then you scale up to the more complicated ones that have extra features essentially. And if you want a kind of like really well done state machine, you can check out the GD Quest video on state machines, and it has more features, that one does, but it's really well done. For this, we're going to use a simple one, and I like to use an enum and a match case for my states. So at the very start of our code here, we're going to write enum, and then just put curly brackets like this. And then I'm going to hit enter, and then we can create two state enum variables here. So the first one is going to be move, and the next one is going to be climb. And we'll put a comma after each of these like this. And you can actually do it this way too, for smaller lists. For a smaller list, we don't need quite as many. Since it's a small list, we don't need to tab down each time. Now what this does is it creates essentially two constant variables. Well, constant and variable are the opposite, but it creates two constants. One called move, which is set to 0, and one called climb, which is set to 1. And if we were to add more here, each of these would be set to the next letters in sequence too. That's enum stands for enumeration. So we'd have A is 2, B is 3, C is 4. So 0, 1, 2, 3, 4. It starts counting at 0 by default, but you can actually set the first one to 1 like this, and then each one will count after that. So this would be 1, 2, 3, 4, 5, like that. But for our use case, we only need the 2, and it's okay if it starts at 0 because the actual value doesn't matter. So we've got our enum set up. Now we need to create and that's just going to make our code a little bit cleaner. So we don't have to use any strings, because you could do this with strings, string literals. We're going to set up a variable here called state, and we're going to set it equal to move by default. Now we're going to come down, we're going to create two new functions, and these functions are going to represent each state. So we're going to create a move state, and we're going to create a climb state. Okay, So how a finite state machine works is that your physics process, or whatever is running your code, is going to run a different code depending on which state you are in. And so if our state variable is set to move, we're going to run the move state. And if our state variable is set to climb, we're going to run the climb state code. And they won't ever run at the same time. And that's the benefit, is that, well, first of all, it makes it easy to debug. If you have an error in your code and it's in the move state, then you know to check there. You don't even need to look at the code in the climb state. And then it also helps with not having a bunch of checks, like, are we on a ladder? Okay, don't apply gravity, because we don't want to apply gravity on a ladder. But if not, we do want to apply gravity, because when we're not on a ladder, we want to apply gravity. So it can remove a bunch of if checks like that. So the first thing we're going to do is we're going to pay close attention here, because this part could be easy to mess up, because I'm going to move code. We're going to start from where it says animated sprite.frame equals 1. We're going to copy this code. We're going to copy all the way to here where it says if input.x equals 0. So make sure you have this code selected. And then I'm going to do Control X to cut it. And then I'm going to paste it right here in our move state over the top of this pass. Boom. Now we're going to get an error here, because you can see that this if statement is actually indented twice, and it shouldn't be. When we copied it over, it added an extra indentation there. Okay, now that it's back, we're getting a different error, which is input isn't declared in the current scope. Now we're going to pass in the input. That way we can get a single input and pass it into both states. So inside of our move state script here, just put input as a variable that we're going to pass in. Now that should remove our error, and we can also do input down here in the climb state. We can remove some of this extra space here. Now our apply gravity is going to need to be applied in the move state. So this is up here at the top. So we're going to actually copy this too, do Control X to grab the apply gravity from our physics process, and we'll press return on our move state and Control V to paste that right here at the top of our move state. Now in our physics process, we can actually just call move state and pass in the input like this. Now we're just calling this function, and it has all of our code in here, okay? And if we run the game, it should work exactly like it did before. We still don't have a climb state, but it should work now exactly the way that it did before. So if it's not working exactly the way it did before, double check your move state to make sure it matches mine. And double check to make sure that your physics process now looks like this, because those are the places we've changed. Now what we need is, well, I actually want to bring up here real quick, somebody mentioned that there's a new function that is a shorthand for this, get action strength, where we can just do input.getAxis and then do UI left, UI right. So this function right here is a shortcut for, this was in the comments and I didn't know about this, so this is really cool. I really appreciate when you all make suggestions like this. This is just a shorthand for using what we did before. Oops. This. Yeah, it's a shorthand for this. So they do the same thing. Only you do have to swap these. So left goes on the left side and right goes on the right side. Which makes more sense, honestly, anyways. Now we're going to do the same thing for up and down too. Input.y equals input.getAxis UI up UI down. There we go. we need the up and down inputs for our climb state so that we can move around in the world. So let's actually make our climb state. We'll come down here and we'll just say velocity is equal to input times 50. And then we'll say velocity equals move and slide. Velocity vector 2.up. Okay, so now we have a climb state with simple movement and then a move code. Okay, and now if we swap this, instead of saying move state, swap it to climb state right here, and we run our game, our character can climb. But they can also climb infinitely without a ladder. They can climb air. But we now know that that state is working, so that's good. Okay, now we need a way to check in the physics process which state we're currently set to, and then to call the appropriate function based on that state. Now you could do this with an if and an elif statement. So if state equals move state input, elif state equals climb state input. We could do it this way. And this isn't a bad way to do it, actually. If you want to leave it like this, you could. But I'm going to teach you a match statement first real quick. So in Godot, there's a thing called a match statement, which kind of is a shorthand for this right here. And match statements are similar to switch statements if you've used a different programming language before. So what we're going to write is match state, and then we'll just say move state input, climb state input. So this and this are essentially the same thing. And it just says when match state, this is the variable we're matching with, and if it matches move, then do this. If it matches climb, then do this. Okay? Now we've got a really simple state machine, and our state is obviously set to move, so now we're going to be in the move state. But if we were to switch our state, why is this up so high? Goodness gracious. If we were to switch our state to climb, this enum value, then we would be in the climb state. And our match statement would be working properly. So now, changing between states, right? We have an easy way. I'm going to switch this back to move real quick. We have an easy way to change states, but we need to have code that is going to do that for us. So inside of our move state, at the very top, and you want to have your transitions to states inside of the state. So we wouldn't want to have a check outside of here, like if is on ladder. Why doesn't it remember? Why doesn't, like, we have this function, but it doesn't seem to know we have it, which is interesting to me. Anyways, if is on ladder, we wouldn't want to put this inside of the physics process. You want to keep all of your logic for your transitions between states inside of the corresponding state. So inside of our move state, we'll say if is on ladder state equals climb. Okay, so now we have a way to transition to the climb state from our move state. If we're in the move state and we're on a ladder, then we'll update our state to be the climb state. And if we run the game, we can see that as we come over to our ladder, boom. Once we touch the ladder, we switch to the climb state. It's amazing. But then we never leave the climb state. We can still climb in the air. So Now we just come back to our climb state and we say if not is on ladder, state equals move. And now we have a way to transition out of our climb state back to our move state. So when we get to the top, now we're no longer in the climb state. We're now inside of our move state again. Really cool. However, it feels awkward to immediately transition to the climb state right when we touch the ladder. Usually games, platform games, will force the player to press the up key. So inside of our move state, we'll say if is on ladder and input.is action pressed UI up. Now make sure that the input you're doing here is the global input, uppercase input. This lowercase input is the one that we created and passed into our function, and they're different. This one just is a memory of our input as it is set as an axis, like with up, down, left, and right. So we're going to check this global input and see if we're pressing the up key. And now you can actually jump into our ladder. We don't switch to the climb state unless we press the up key. And if we're pressing the up key in the ladder, then we can switch to the climb state. And there we go. That allows you to like walk off this edge here. And we also, because we're using move and slide, we automatically collide with the bricks here and don't actually go into them while we're moving on our ladder. Now, we want our character to animate while he's climbing the ladder. Even though we don't really have a climbing animation, we're just going to use the running animation. And we can do this inside of the climb state by saying if input.length does not equal 0, animated sprite dot animation equals run. Else animated sprite sprite dot animation equals idle. So now if our input, if we're actually moving, if our input's length is not 0, it's similar to this check right here in our move state where we say if input.x does not equal 0. Only this time we're checking the length of the input, which means it could be up, down, left, right, any length. If it's not equal to 0, we'll set it to run because that means we're moving. If it is equal to 0, we'll set it to idle because that means we're not moving. Okay, and now our character will animate while going up and down ladders. It looks a little silly, but I think it looks better than just not doing anything. And there we go. We now have a fully functioning, working ladder with our nice state machine. Now one thing you can do is you can use these little arrows to hide your state logic so that you don't see it at all times. You can do it with all your functions actually, which can be nice. You've got your base. This is like where all your code is run. And then you've got functions for the different things that you're using. And we've got, it's pretty good. It's looking pretty good. So that's going to be it for this video. We're almost 30 minutes in, but we covered ladders and a finite state machine. So we covered a lot. Our character and our game is looking really good. Hope you guys are enjoying this series and look forward to the next 7 or so videos in the series until we complete it. Thank you all so much for watching, and I will see you all later.